Math is a wonderful thing. Math is a really cool thing. So get off your ass, let's do some math. Math, 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 math.
Hey, Algebra 1 students. So welcome back. Here we are with 5.6 on graphing linear inequalities in two variables from the big ideas. Today what we're going to be looking at is graphing linear inequalities. So we're going to graph some lines again, but then we're also going to be doing some inequalities, which means we're shading part of that coordinate plane as well. So we're checking first of all to see if there's some solutions of inequalities. We'll do that first, just checking some ordered pairs to see if they are solutions to inequalities. Then we'll graph them in a coordinate plane as well. So let's get started here. So I have a little cartoon of the day to start with. Two snowmen there. Their lightsabers come to the dark side. There's more shade. That's good. Little Star Wars characters in the snowman. All right, as we come to linear inequalities, here's where your vocabulary is. So this is going to be on page 159 in the journal book. So if you're looking at your journal book, page 159 at the top, you'll see your vocabulary. And so when it says a linear inequality in two variables, this is what I would like you to put down. At least there's four of them. There's four possible ones here because we have four possible different inequality symbols. You just need to write down one. And so you can just write down this first one, the ax plus by, and then some inequality sign, and it could be any one of these four. So you might want to mention, you can put this one down, but then you can maybe say, okay, it could be also less than, or greater than, or equal to. Any one of those would be fine. But it's an inequality here in your standard form. So this is a standard form of a linear equation, except instead of an equal sign, there is now going to be an inequality sign. And so that's what you want to put down for just a linear inequality in two variables. And then we look at a solution. So what is a solution of a linear inequality in two variables? That is simply just an ordered pair, like an x and a y point, that makes the inequality true. So you want to write that down as well for the second vocabulary there on page 159 of your notes. So what we're going to do first is check some ordered pairs. They're going to give us an ordered pair. We're going to plug it into the x and the y into the function, our linear inequality function here, and then we'll see if it's true. If it's true, then it is a solution. If it's not true, if it's a false statement, then it would not be a solution. Okay, so on your extra practice, now we're looking at page 160 there in our notes. So this is on page 160. I'll put that up at the top here. And I'm going to do 3 of these, and then I'll have you try 3 on your own. So let's start with number 2. I'll do the even ones on this page, and then you can come back and do the odd ones. So if we're looking at tell whether the ordered pair, so they give us their ordered pair, and this one's 5, 3, is a solution of the inequality. So we're going to plug in, this is our x, this is our y. So for x, we're going to put our 5 here, minus the 3, and then it's less or greater than or equal to 2. And so 5 minus 3 would be 2, so greater than or equal to 2. So is that true or false? So 2 is not necessarily greater, but it's also equal to. So is 2 equal to 2? Yes. So we could say, yes, this is a solution. Yes, it's true. Yes, it's a solution. So that's kind of what you want to ask yourself. Is it true? Yes or no? And if it's yes, it's a solution. If it's no, it's not. Number 4, if we come to this one, here we're going to plug x and y. 2 is x, so 5 times 2, and then plus y, which is negative 2, I'll go and put that in a parenthesis there, is less than 7. So that's going to be 10, and this is negative 2 is less than 7. So 10 minus 2 is 8, so 8 less than 7. So is 8 less than 7? No, that's not true. So this is not, no, this is not a solution. So no on that one. It wasn't a true statement. 8 is not less than 7. So that means that this ordered pair is not a solution to this inequality. On number 6, x is negative 2, so it'll be a negative, and then times a negative 2. minus 2 times y, which is negative 3, and it's greater than or equal to 5. And so negative times negative is positive, it's going to be 2 there. Again, negative times negative is a positive there, so positive 5 is greater than or equal to 5. So that's going to give us 7 is greater than or equal to 5. And is this true? Is 7 greater than 5? Yes, 7 is greater than 5, so yes, that is true. Yes, that is a solution. All right, so what I want you to do now is go ahead and pause the video for yourself and then do number 1, 3, and 5. Do the same thing there. Just find it out if it's yes or no, and then play it, and then I'll start showing you again. So pause the video and do 1, 3, 5, and then play it to see your answers. All right, hopefully you got your answers for 1, 3, and 5. Let's go ahead and check these here. I'll do these ones in blue. So this one's going to be, you would say 3 plus 2 greater than 5. And 3 plus 2 is 5. Is 5 greater than 5 though? No, it's equal to. So this would have to be a no. Okay, because 5 is not greater than itself. Number 3, you're going to be putting negative 1 here for x plus 2 times 2 less than or equal to 4. And so it's going to be negative 1 plus 4 less than or equal to 4. So take 1 away, it's a 3 is less than or equal to 4. Is this true? Yes, 3 is less than 4. So yes, that is true there on number 3. And then for number 5, you're going to be saying 3 times x. X is negative 1 minus 4 times y. Y is also negative 1 greater than 6. And so we're going to get negative 3. And then this is going to be double negative, so you're going to be putting plus 4 greater than 6. And if you take 3 away from 4, it's going to give you 1 is greater than a 6. And that is not true, so that means that ordered pair is not a solution. No, it's not a solution to the inequality. Okay, so we're going to use this as we kind of go forward into graphing a little bit. I'll show you kind of how we could use this to check our solutions, to check to see if we are correct on our graphing. All right, let's move on to the next part here, which is graphing linear inequalities in 2 variables. So for this one, what you want to put down, so graph a linear inequality in 2 variables, basically if you go back to 159, where your vocabulary is, write down for this vocabulary part, just that it shows right here that a graph of a linear inequality, it shows all the solutions of the inequality in a coordinate plane. Let's go ahead and write that part down right there. It shows all the solutions of the inequality in a coordinate plane. And that's what this graph is demonstrating here. So this is our inequality graphed. Our linear inequality is graphed. And so the graph of it shows all of the solutions. So the shaded part represents where all the solutions are. And what we see in our next vocabulary is this thing that says half plane. So the half plane, what should you write down for half plane? You can see it says here that the boundary line divides the coordinate plane into 2 half planes, and the shaded half plane is the graph of the inequality. So here's what you would want to write for a half plane here. I'll put it down maybe below here. What you could write, I'll put this in red, is that 2 regions, which are one region here, one region there, of the coordinate plane divides the boundary, the coordinate divided by a boundary line Okay, so it's boundary line divided by a boundary line. And then also you want to put down this here. The shaded half plane is the graph of, and you can, instead of, you don't have to write this, you can say inequality here. There's an E there. Try that again. Inequality. So you can put down for half plane 2 regions of the coordinate plane divided by a boundary line. I forgot the line there. Divided by a boundary line. There's an R in there. Or Y, actually, isn't it? Yeah, that's an A-R-Y. Okay, so that's what we're going to be graphing on our own for the next several problems. We're going to be graphing the line first, and then we're going to need to figure out which of the sides we're going to shade. And the graph of the line, you can see it's a dashed line. Sometimes it's going to be dashed, sometimes it is going to be solid line. So we'll see that here on our core concept. So I'm still on page 159 of your notes. Look down at the core concept. Again, if you needed to rewind and see this again, you can always come back to see this. So our core concept here, it starts out with step number 1. It wants to graph the boundary line of the inequality. But here's the key thing, is that you need to use a dashed line. So use a dashed line for when you have it like this, when they don't have the equal sign, and you use a solid line for when it does have the equal sign. Okay, so if you have an inequality with the little line underneath it saying it's also equal to, use a solid line. But if it's going to be like this, where it's just no line here, it means it's going to be a dashed line. It's like an open hole. When we used to do it on a number line, we used to do either a closed hole or an open hole. This is like an open line as a dashed line. Okay, so once you graphed your boundary line with either the dashed line or the solid line, then you need to figure out which side you're going to shade. And so what we're going to do, this is here we can find a test point. We can test a point on the boundary line. Now I don't usually do that though. So typically step 2 and 3, this is one way you can do it. You can use a test point to kind of see, is that test point going to be a solution? And if the test point is a solution, you would shade that side. But if the test point's not a solution, then you'd shade the opposite side. Okay, because you have your 2 regions of that half plane, right? You have the 2 half planes there divided by the boundary line. So here's what I typically do. What I do is in this kind of step 2 or 3 here, what I typically do is, I'm going to put a little or here, I plug in x equals 0 into my equation, and then I get an inequality just with like y is either, some inequality to some number. And so then all I do here is I shade according to the y-axis. According to the y-axis, and I'll show you how I'll do that here in a minute. So plug in x equals 0, and I'll do that for you. I'll demonstrate that. And then I just shade according to the y-axis. For me, I've always found that to be much simpler than to try to do a test point. The test point is helpful, though, to check to see if that is correct. So if you do this, we'll test some and just check to see if they're correct. All right, let's go on and take a look here. So on this one, here's just a quick example. You don't need to write this down. It just says, graph this in a coordinate plane. Y is less than or equal to 2. All right, and so you'd first graph the boundary line. Since it's got the line there, it's a solid boundary line. And now you have to decide which side to shade. So here's where they would say, pick a test point. So if you picked a test point below at 0, 0 and tested that test point, basically plugged in 0 here, is it true? 0 is less than 2. Yes, okay, that is true. So that means you would shade this side down here where your test point was true. But if that was false, then you'd shade the opposite side. So you can't always do that. But here's kind of what I do. I plug in 0 for x. Now there is no 0 for x because there is no x in this one. So you can just see that y is less than your graph line. Y is less than your boundary line. And so it's less than, basically the less than is going to point down. So it's definitely going to go below the line. So you kind of go off of just the y-axis. Less than on the y-axis is going to be down below. And so that's what they're showing here. You're going to shade down below. They did the test point. It was true. They shaded down below. I would shade down below too, just by realizing that y is less than the 2. So it's going to be below. All right, so let's go ahead and try some of these. I'm going to do a few of them. I'll do 3, and then you can try 3. I'm going to start with number 8. So let's start with number 8, which is y is greater than -1. So now we want to graph this. This is just a horizontal line. When it says these are either horizontal or vertical. The one that has y is going to be horizontal. The one that says x is going to be a vertical line. So we should have gone over those in previous lessons of just graphing horizontal and vertical lines. So if you're missing one of the variables, it's going to be just either straight across or straight up and down. In this case, you first go where y is -1. -1, that's going to put us right here on the y-axis. So it's going to go straight through that line. And so what we would notice here is that it's one of those that are like an open hole. It's not equal to, so it's not solid. It's going to be a dashed line. So we now have to put a dashed line going across here. So put yourself a dashed line. That's driving the boundary line. And now, just based on this, we can see where is it here. Since it's just got one inequality, y is greater than -1. Greater than -1 is going to be up above. So we are going to definitely shade up above here. So we'll shade up on top. Go and just shade it with my highlighter here. So that's where we shade. All right, let's try another one. Let's do number 9. Come and do number 9, just the next one over. So this one says x is greater than 3, so it's got the x this time. So we have to go to 3 on the x-axis. 3 on the x-axis is right here. Now this one's going to go through the x-axis, so it's vertical, and it also is going to be dashed because it doesn't have the equal to, so we're going to put a vertical dashed line just straight up and down. Put arrows on the end. And now we got to decide, are we going to shade on the left or on the right of this line? So you can see what it says here. X is greater than 3. So greater than 3, 4 is greater, 5 is greater. We're on this side of the line. So we have to shade on that side of the line. So it's going to be, the shading is going to be over here. This is where all the solutions would be. So if we picked a solution out of here, so if I just said, let's say this point right here at 4. So if I say that'd be 4, 0. So x is 4, 4 is greater than 3 is true. But if I picked a point on this side and said like 2, 2 is greater than 3 is not true. That's why you don't want to shade on this side. Same thing you do here. If I wanted to pick, let's just say 1. 1 is on the shaded side. So I plug in 1, 1 is greater than -1, and it's true, so it should be in the shaded region. And if I look over here, like let's say -4 down below, -4 is greater than -1, that is not true. That's why we wouldn't shade down there. So we're going to shade everything in this region on this side of the plane, this half plane up here. On the shaded side, every point, every ordered pair is a solution to that inequality. So it shows a region of infinite solutions to this inequality. Let's do one more. I'm going to come down and do number 11, and then I'll let you try the other 3. So number 11's got y is less than -2. So we're on y again, so y-axis -2, we're right here. And it's going to be straight across, and it is dashed because it's not equal to, it's just going to be a dashed line. It's like open, like an open line. So a dashed line going across here. And it says y is less than -2. Less than -2 is down below it. So we should be shading below this line down here. Everywhere below the line is the shaded region. All right. And again, if we want to pick a test point, if I said 0 right here, if I picked 0 as my test point and put 0 here, 0 is less than -2, that is not true. That's why I would be shading this side and not this side. On this side, all of these are true. -3, -3 is less than -2 is true, and so on. All right, so go ahead and pause the video and do 7, do 10, and do 12, and then play the video to check your answers. Okay, so hopefully you've done now 7, 10, and 12, and you're just going to check your answers. So our answer for number 7 should be a dashed line going through here at 4. And the shading is down below it. It's less than. So all this section down below is shaded. Number 10. On this one we have a line at 1, but it's a solid line. This one's going to be a solid. Everything has been dashed so far, but this is a solid line at -1. 1 on x is -1 right here. So solid line going straight up and going straight down. There we go. And on this one, we're going to be shading off to the left side. It says less, x is less than. So we're shading off to this side. Everything over here on this side of the graph is our shaded region. All of that is the section of all the solutions to the graph. And then number 12, this one's going to be also another x1, so it's vertical. So right here at -2 on the x, and it is a dashed line. So this one, we got to make it dashed because there is no equal to on this one. So equal to means it's a solid boundary line. And now this one's going to be shaded on the right side. It says x is greater than that. So it's over here on this side, everything on this side. And we just got to shade the window that we see here. Obviously, it just keeps on going this way. It keeps on going up and down, so that's why it's infinite. It's an infinite amount of solutions anytime you do inequalities. All right, let's come on to the next part here. Well, before we get to the next part, we'll go and pause for this joke of the day. So here you go. What is a dog's favorite school subject? Favorite school subject? You might think, is it math? Is it history? Is it English? Well, maybe you didn't think of this. It's doggraphy. Doggraphy. So it kind of sounds like geography, but no, it's doggraphy. Maybe the study of dogs, I guess. All right, moving on. So here we're going to look at now graphing some of these in a coordinate plane. So here's one we're going to graph. It's not a horizontal or vertical. This is a diagonal line. So you can see how we graph the line first. It is dashed, okay? And then we're going to shade one side or the other, either above or below. So here's where I would be thinking about, okay, is it going to be, is the y, and I always go according to the y. That's why I plug in x is 0. If I plug in 0 for x, and I really do it kind of right here, that means it's just +1. So it would be greater than that 1. So it should be shaded up above here if it's greater than 1, which you can see it is. So you're using the greater than symbol, that's greater than, and then it's 1 here. Y would be greater than 1. And so let's go ahead and try a couple of these here. So I'll do 3 again, you do 3. I'm going to start with number 14. Actually, we'll just do out of these 3 here. Let's see, 13, 14, 15. I'll do 14 and 15, and you can come back and do 13 on this one. So first of all, 14. First thing we want to try to graph is the boundary line. So it's a y equals mx plus b line. Remember, that's what we're talking about with linear functions. Y equals mx plus b, that is slope-intercept form. So in the one, like number 15, is standard form. We're going to want to first change it into slope-intercept form so that we can make it easier for us to graph. So on this one, we're going to start with our y-intercept. Remember, the b is the y-intercept. So this is our starting point right here, is 1 on the y-axis. That point is the y-intercept, where it crosses the y-axis. So +1, we're going to put a point. Now we find the next point with our slope. Our slope right here is the m, the number in front. So m in this one is -1, and you can always put that over 1. So we're going to go down 1 and right 1. So down 1 and right 1. We're going right there. Now we can keep doing that, down 1, right 1, down 1, right 1 every time. We can continue to do that one up and down as long as we want. So we can notice it is a solid line here on this one. So we're going to make a solid line out of this. So that's why it's helpful to put all those little dots down there. Now I do know it's going through this grid. So I do know it's going to come up through that point, and then it's going to hit that point. It's kind of hard for me to draw this on my thing here. So that's about good, I think. There, it's all solid. Okay, so now we need to decide, are we going to shade above it or below it? So according to the y-axis, you're either going to be above 2 or above 1, or you're going to be below 1. So here's where, again, I plug in x equals 0. So I plug in x equals 0 here, we're going to see that it's going to say what y is greater than or equal to negative 0 is going to be 0 plus 1. So basically I plug in 0 here, it goes away, and we just have the 1. So we end up with this. Y is greater than 1. Greater than 1 is going to be up above it. So we're going to be shading on this side of our line. So this is the side that we would shade. All of the side right through here. And we can pick a test point. Here's where the test point is definitely a helpful thing to just double check yourself that we did do this correctly. So if I wanted to try, let's just say maybe this point right here, 2, 2. So I plugged in 2 for y. So 2 for y is greater than or equal to, and this is going to be 2 for x, so it's going to be negative times 2 plus 1. So 2 is greater than or equal to, this is going to take 1 away, negative 1. Is 2 greater than negative 1? Yes, that checks out. So that is true. It's on the true side. It's on the solution side. So everything, any point over here would make this inequality true. Okay, let's go to 15. Now 15, we need to first adjust it, put it back into y equals mx plus b. So let's do that first. First thing I got to do is subtract my x from both sides. So I'll write it up here. So now it's going to have a negative y is less than negative x and then a positive 2. But now I can't leave it as a negative y. I'm going to have to multiply both sides here by a negative sign. Put the negative right there. So negative times negative will give me now positive y. But here, whenever I multiply an inequality by a negative, I have to switch the direction that sign goes. So here's where you got to remember that little rule for inequalities. Switch the direction for the sign when you multiply or divide by a negative. And we are multiplying by a negative here. Negative times negative is a positive x. Negative times positive is negative 2. Okay, so now we can see our y-intercept is going to be negative 2. So negative 2 is our starting point. And then our slope here is 1. So we can say m on this one equals 1. It's 1 over 1. So that's just going to be up 1 and right 1. And I can keep doing that as many times as I want to. And it's going to be dashed here. So we're going to do a dashed line. In fact, I'll just do the dashes through each of those little pieces right there. And dash through that point, dashed all the way down. Okay, so again, now we need to decide, do we shade above it or below it? So above on the y-axis or below on the y-axis. If I plug in 0, I'm going to do it to where I have the y equals mx plus b. If I put 0 here, that's going to give me y is greater than negative 2. So y is greater than. That greater than means it's above. So the shading is going to be up here, up above the line. So if you just go according to the y-axis, is it greater or is it less on the y-axis? In this case, it's greater. Y is greater. So greater would definitely be going up. Less is going to go down. So if this was a less than sign, I'd be shading on this side instead. And you can always double check yourself. We can even try 0, 0 as a test point. If I plug 0, 0 in either one of these, let's just try it to the original one. That would be 0 minus 0 is less than 2. That's 0. 0 is less than 2 is correct. So it checks out. That test point is on the correct side where we shaded it. All right, go back and pause the video for just a moment. Do number 13 and then check your answer. All right, so hopefully you've gotten your answer for number 13. This one is in y equals mx plus b form already. So we're going to see, we're going to be putting 1 here. And the slope is 3. M is 3. 3 over 1. So it's going to go up 3 and right 1. 1, 2, 3, right 1. There it goes. Now you could also go down 3 and left 1. That's going to also be on the same trajectory of the line. And this one is a dashed line. So we want to make sure we do a dashed line. It is kind of hard for me to do that. If you had a ruler, it would be way easier to make yourself a dashed line here. So this is very challenging to do a dashed line, but I'll do my best here. Try to do this dashed line. So something like that. Alright, so that would be our line right there, and then it says that y is less than this line, so it's going to be less than, so less than is going to be down below. It's less than R1 here, so it's less than this 1. If you plug in 0, it's less than 1. Y is less than 1. Less than 1 is down below here. 0 is less than 1, all the things down here. So you can see that's why I say plug in 0, and then you can just do it according to the y-axis. Y is less than 1, you notice shade on this side of the line, on this side of your half plane. Alright, let's come to the next three problems. 16 to 18 is next. I'm going to go ahead and do number 18, and then I'm going to have you try number 16 and 17 on your own. So number 18. Now 18 again is in standard form. This we need to change to y equals mx plus b. So what we're going to first do is add our x term. Add 2x. That gives us a 3y, and it's greater than, put the x first, 2x, and then it's a positive 6. To get rid of the 3, we need to divide by 3. Now we want to divide both of these by 3 individually. So that means it cancels our 3's here. It leaves us with y still greater than. We don't switch the sign here because we're not dividing by a negative. If this was a negative 3y, we would have switched the sign. Now we have a 2/3 is the fraction. 2/3 x, and then 6 divided by 3 is 2, so 2 is there. So this is our y-intercept right here is 2. So 2 is our y-intercept. We're going to plot that down first on the y-axis. And then our slope is 2/3. This is our m. So 2, go up 2, and go right 3. So they're both positive. Up 2 is positive, right 3 is positive, and there's another point. We can go the opposite way. We can go down 2 and left 3, and that would put us there. It is a dashed line, so let's go ahead and try to put our dashed line here. And this direction. And here's where we're going to now go off of right here, your new y equals mx plus b right here. If I put in 0, y is going to be greater than 2. Greater than 2 is going to be above. 4 is greater, so you got to shade this side of the line. Up here on the top. That's going to be our side. Oops, that's not it. That's it. So everything over here above the line is going to get shaded. And again, we could check a test point if we wanted to. If we did that, I'll just pick a test point real easy here. Let's just try this one here at 4. So that's 0, 4. So that would be a 0, 4. If I plug that into here, negative 2 times 0, just like we did on the first few problems, plus 3 times 4 is greater than 6. And it's just a way to check to make sure you did shade it in the right side. That's going to be 0, negative 2 times 0. This is going to be 12, greater than 6. So is 12 greater than 6? Yes, that's true. So that gives us confidence that we know we did it correct. All right, go ahead and pause your video again and do number 16 and 17 and see if you can get those correct. All right, let's check out your answer for 16. This one we need to solve for y to get it into y equals mx plus b. Very simple though, we just need to subtract x, that's all we gotta do. So your y equals mx plus b would be y, inequality sign. Now we're not switching that, even though we're subtracting x, so you don't switch it when you subtract. It's only when you multiply or divide by a negative is when you change the direction of the inequality. So remember that. And then we have our negative x and our minus 3. Our minus 3 right here, that's going to be our y-intercept. So negative 3 is right down here. That's our first starting point. Negative x, that's a negative 1. So m equals negative 1 over 1. So you can see you're going to go down 1 and then right 1. Down 1, right 1. Put you right here. You can do it again there. We can go up 1 and left 1. Same trajectory on the same line. And it is solid. As you can see, it's got the little line underneath there, so it is a solid line here. So we want to make that a solid line. And I like to go all the way up, the entire window. They give you this little coordinate plane is like the window that they're giving us to see. It's an infinite plane. These are always infinite because that's why the arrows keep going. But so you want to always just go all the way across it. Don't just put like a little tiny line. Make sure you use the entire window. And now we're going to shade. All right, here on this one, it's greater than. It's going to be greater than -3. So greater than is going to be up above on this one. It's everything up above here. There we go. So any test point, you could put 0, 0 in fact. 0, 0 is easy to see mentally. If you put 0 and 0 here, that makes 0 is greater than -3, and that is true. So your 0, 0 test point is definitely on the 0 on the true side. On this one, we got to first subtract the x on that. So that gives you a 2y is less than -x and then a +4. Then we got to divide by 2. So we're dividing here by 2 and we're dividing here by 2. So your y is less than, this is really a 1 in front of x, so it's -1/2. -1/2 x. Okay, because it's 1 over 2. And it's a -1 over 2. So that becomes -1/2, and then 4 over 2 is 2. So again, here is your y-intercept. That's our starting point is the 2. And so we'll put 2 right there first. And your slope, you can say negative will go with the 1, so it's going to go down 1 and then right 2. It's downward slope. Downhill is a negative slope. You can see this one was a negative slope, it's going downhill. This was a positive slope, it's going uphill from left to right. We could also go up 1 and left 2, puts us on that same trajectory. And it is going to be a dashed line. Might be helpful to put a couple more there. Points, so you can see where you're headed. And we need to make this into a dashed line here. So kind of put some dashes along the way. An arrow on that side. And some dashes up this way as well. Alright, and so this one, if we go off with the graph here, if you put in 0 here, it's going to say y is less than the 2. Less than 2 is going to go down below it. That's where we got to shade, is everything down below. All our shading is down here. So you can shade that as neatly as you want to. I'm not showing you that's where it would be. And again, we could try 0, 0. 0, 0 is an easy test point to mentally do. If that's 0 and 0, that's going to all be 0. 0 is less than 4 is true. So that is definitely on the true side. All right, let's come to our very last one, number 19. We are now at the bottom of 161 in your journal book. And so with this one, it's a kind of more problem where we have to write out our linear inequality and then go ahead and graph it. So we have to make it up from the information they give us here. So an online store sells digital cameras and cell phones. So there's two things. They sell cameras and they sell cell phones. Store makes $100 profit on the sale of each camera. That's going to represent the X. So X down here, these are going to be the cameras. Okay? And then $50 profit on the sale of each cell phone Y. So we can go up on this side. These are going to be cell phones up here. Okay, the store wants to make a profit of at least, that's very important, that's going to be the inequality. That's your inequality sign right there. I'll put down maybe a inequality sign. That's the inequality right here, that wording, the at least. So when it says at least 300, that's going to be the inequality sign, then 300. From its sale of both digital cameras and cell phones. So and means you're going to add them together. Okay, we're going to be adding these together, the digital cameras, the profit of them, and the profit of the cell phones. So we're going to write and graph an inequality that represents how many digital cameras and cell phones they must sell. Again, it's going to be a region, so it could be a combination of them. There's not just one specific ordered pair. And then lastly, we'll identify and interpret two of the solutions of the inequality. So first we got to write this thing out. So again, remember, X is the cameras, and they make $100 profit on every single one. So for every camera they sell, they're going to make $100. So if they sell one, they make 100. If they sell two and X is 2, they make 200. We're going to add that, because it's cameras and cell phones, add that to the cell phones, and they make $50 profit on each cell phone. So for every cell phone, 50Y. So if Y was 1, it's $50 there. If Y is 2, it's 100. And then it's at least. It's at least the 300. So this needs to be, could be equal. They're okay with being equal, or they want even better to be greater than 300. They want it to be at least. So it's greater than or equal to. Okay, that's what we're talking about. At least is at least that, so it's, it's equal, but even better would be greater. So greater than or equal to the 300 number. There's your inequality. Now let's write this. So we wrote this out, so that's the writing part. So that's part of our answer there. Now we got to graph it, but to graph it, it'd be easier if we put this into slope-intercept form, the y equals mx plus b form. So I'm going to subtract 100, do that so I'm going to subtract 100 from both sides, 100x, and that's going to give me 50y, my inequality sign, negative 100x plus the 300, and then we divide by 50. We're going to divide each of these also by 50. So y is greater than or equal to, here this is going to be a negative number, and 100 divided by 50 is 2, so it's negative 2x. 300 divided by 50 right there is 6, so it's 6 then. And you can see these are all out in just number form here. So we see 6 for the y-intercept, that's our y-intercept number. So we're going to graph 6 first on the y-axis. Right now we just have a coordinate plane of just only the first quadrant. Everything's positive over here. Obviously they don't want anything negative. They don't want a negative profit. And then our slope on this one would be negative 2, so negative 2 over 1. So I go down 2 and left 1, or right 1, sorry. Down 2, right 1. I can keep doing that. Down 2, right 1. Down 2, right 1 takes me all the way here. And it is a solid one because it's equal to, so it should be solid. And now we just got to shade. So the shading here, if I put in 0, y is greater than the 6. Greater than the 6 is going to go up above, so it's everything over here. So our shading of this graph is everything on this side. Now it wants us to, that's these two things. Now we need to identify and interpret two of the solutions. So we can pick out two solutions. Let's say if I picked 3, 5, so 3 and then 5 right here. So that's a 3, 5 solution. And we'll pick another one at 6, 4. So 6, 4 is on this side. Obviously the solutions is going to be on the solution side. This is 6, 4. Now let's go ahead and interpret those. For 3, 5, 3, 5, what that means would be that they have 3 cameras sold and 5 cell phones. Purchased. So if they have, if somebody or several people purchase 3 cameras and 5 cell phones, they will definitely make a profit of at least 300. Let's go ahead and do 6, 4, same thing. Go ahead and we can see that's going to be 6 cameras for X. Okay, so 6 is X, so 6 cameras. So if they sell 6 cameras and 4 cell phones, that also would give them a profit that they would want. That is at least 300. So anything in this section over here, any ordered pair in this section, any combination of cameras to cell phones is going to give them at least 300 profit. If they're over here in this section, like let's say right here, 1, 2, if they're on that spot right here, then they're not going to make as much. You know, because if they say X is 1, you know, that's going to be a camera's 1, they get $100 for that. And they got 2 is the cell phones, they make 2 of those, so they get $100 for that. That makes them only a profit of 200, not, they didn't reach the 300 mark that they wanted to be at. So that's why it has to be in the shaded region for them to do that. All right, so that concludes our lesson here on and I'll see you on the next one.